I'm Nicolò Sordoni. I work as technical lead at Tantrim. I'm also the chief meme officer of the company, but don't worry, no meme has been used for this presentation. You can find me at GitHub or Twitter at the nickname that you see at the bottom of the slide. In my GitHub channel, you can also find the examples that I'm going to show you. Actually, they're private, but I'll make it public just 10 minutes after the presentation. I suppose the ones of you with an accent in their name or surname already know what my nick refers to. For the other one, it's about the mail that I keep receiving from mailing lists that don't know how to manage correctly encoding, but that's life. So, Flutter Navigation 2.0. Why did we have the need for a new version of an existing API? I'll start by showing you a comparison of the 1 and 2 version of the navigation API. In the left, you can see the first version where everything was imperative. So in order to navigate to a new route, you had to make a push. And to pop, you have to invoke the method pop statically on the navigator class. You could either get a reference to an instance of the navigator and invoke it to this instance, but it was anyway an imperative approach. On the right, instead, you can see the new API where you have a build method, which is rebuilt every time that the routing has some changes, and always return a list of pages that depends on the actual application state. So as you can see, is a declarative approach, and it works in the same way that everything else works in Flutter. So it has the same structure as the widget. So it's a tree that contains the pages that must be shown on the screen. So it's much more Flutter style than before. And that's the first big benefit of Navigator 2.0. Then you have much better support for web navigation, for deep linking, and for all the complex case that requires to load, for instance, multiple pages at once, or to remove an off-screen pages, because with an imperative approach, the only way to reach this goal is to pop the pages and to push the new ones that you had to show. Instead, with the declarative approach, you just update this list and return the updated list of pages, so you can easily manage the complex cases. Then a pain point was the nested navigation, because in lots of cases there was the need to have a section of the app with a nested navigation approach. For instance, in a tabbed page, it happens that you have a tab with its own navigation stack, and it was not impossible, but very difficult to reach. And an important goal that has been reached with the new API is to keep compatibility with the previous one. So you can evolve your application to 2.0 without breaking anything. So what's the architecture of this new API? Well, you can see a diagram above the slide. And one of the most important concepts is one that is not shown on the diagram, which is the page. The page is just an abstract class that describes the configuration of a route. You can see the relation between pages and routes is equal to the one that exists between widgets and elements. You use a widget to describe the configuration of an element that is rendered by the system. And the same happens with the pages. You use the pages to describe routes, and that's the system that renders it and that manages it. The router component that you see on the right is the one that does the actual job. but it's a component that you don't implement it or manage directly. You just have to implement its delegates. And the most important of these delegates is the router delegate. What does the router delegate does? It configures the list of pages that must be shown in the application and provide it to the router. So it's the router delegate that says which pages must be loaded, and the router just render it. Another important goal of the router delegate is to listen for every change that involve the navigation. So it listens for modification, updates on the upstate, and whenever a change happens that has impact on the navigation stack, on the pages, it triggers a rebuild. So it's notified the router that something has changes, and the router then requires back to the router delegate the new list of pages. So it's the central component of this architecture. And then we have the operating system that sends to our application some events, and we have to react to this event with 3 different components. The first event that we have to manage is the back button press on Android by the user. So whenever the user press the back button, we have the back button dispatcher component that forward this event to the router delegate. For the back button dispatcher, the default implementation is enough for almost all the cases. So I never had the need to implement a custom version of it. And the same is true for the route name provider. The route name provider receives a different kind of event from the operating system, which is the intent, an intent that requires to show a new page. So for instance, when the user clicks a deep link, or the initial route, which is the first route that must be loaded when the application starts. In both cases, the operating system is requiring to our app to show an URL, a path, and we have to manage this request in order to show to the user the page that has been requested by the operating system. As I said, the route name provider has the default implementation that is enough for all cases, or almost all cases, and it just redirect this request to the route name parser, or RouteInformationParser as the new class is named. And it receive this request from the route information provider in a structure named route information, which just contains the path that we must load. One of the most important goals of the route name parser is to receive the request and to forward it to the router delegate using a structure that is well known internally to our application. So it receives a URL and it must convert in a format that is well known to the router delegate and that allows the router delegate to understand which page we must load, we must show to the user. So we have to define this model. We have to decide how the request is passed from the parser to the delegate. Let's see an example of how this works. Okay, you can see that is a very, very simple case. It's just an app with 3 pages. We have the to-do list that on a browser, it corresponds to the path /, so it's the root, the default page of our application. And then we have the to-do detail, it's a to-do list. We have a to-do detail that on browser, it refers to the path shown at the /to-do/ID of the to-do. Every other path is unknown to our application, so it redirects the user to the error page. How does it work? As I said before, the first thing that we have to do is to define how the information is forwarded from the parser to the delegate. In this application that has only 3 pages, Two properties are enough to determine the correct page that we must load. So we have the property selected to do ID that is nullable because it's true only if the page that we must show is the to do detail. The isError property has a true value when the page is the error page, and all other cases refers to the to-do list page. And then in this class, we have three utility methods that are used only to immediately know which of the three pages the path corresponds to. In the UpRouter delegate, we have a property which is show error, which is used by the router delegate to determine if it must show the error page. It's local to the delegate because it has impacts only on the navigation part, on the navigation section. Instead, the selected to-do ID, it's an information that may have impact on other section or aspect of the application. So I decided to put it in a shared store, which is the application state. Let's see the code to understand better how this works. So we have the Upstate, which contains the information that I just showed to you, so the to-do list, the selected to-do, and has two methods to select a to-do and to clear selection that are used by other parts of the application, so even by the router delegate to configure the application state. As you can see, it extends the class changeNotifier, which is a class that allows to other components to listen for changes and to react to these changes. So whenever the method notifyListener is invoked, every other component that is listening to the upstate receives a new event, a new notification. And the upstate is a singleton. Then let's see the uproute path. That is the class that is used to communicate by the RouteInformationParser to the router delegate which page must be loaded. That contains the two information that I mentioned before, one constructor for each of the three pages, and one utility method for each of the three pages, used to determine which of the three the configuration refers to. The RouteInformationParser has two methods. The first is parse route information, which is invoked whenever the route name provider sends a new event to the parser. So the method parse route information is triggered. The first thing that we check is if the location has a value. Otherwise, it's an error because we don't know how to parse this information. Otherwise, we transform the location that we receive from the operating system into a URI and check to its path segments. If it has no path segments, we are in the root, so we return the to-do list. Otherwise, we check if two segments exist and if the first is /todo. In this case, the system is requiring us to show the to-do detail page. So we return uproute path dot to-do detail, parsing the second parameter as the ID of the to-do. Obviously, in a real case, more controls and check should be done, but obviously that's a demo. Then we have the restore route information. I'll explain to you in a while what that method is needed for, but it does just the reverse operation. So it receives the uproute path and returns a new route information. So for instance, if is the error page, it returns the route information which contains /error as path. The router delegate is the central point of the navigation. It has the show error method that I mentioned earlier. And then when instantiated, it gets a reference to the upstate instance and add a listener. So whenever the upstate changes, the app router delegate is notified. And what does the router delegate do when it's notified? It just invokes its own notify listener, because the router delegate is a change notifier too, and his listener is just the router. We don't need to do anything else because the router is managed by the system. On this pause, the listener is removed. And then we have the build method, which is called by the router whenever he wants a new navigator, whenever he wants to show the list of pages. The navigator has a global key that we have mandatorily to define, and then we have a callback for whenever a pop event is triggered by one of the pages, and it has the list of pages. The list of pages is returned in this case by a private method, and the list of pages is related to the current configuration. If the variable show error is true, we just return a list of pages that only contains the error page and nothing else. Otherwise, we get a reference to the application state, and we return a list that has always the to-do list page, and if a to-do is currently selected in the Upstate, above the to-do list, we put the to-do detail page. As you can notice, I'm using the class material page that has a key which is unique for every page, and the child, which is the UI of the page. Then we have two methods for popping a route. The first pop route is invoked by the back button dispatcher when the user presses back on Android. Then we have another callback, which is on pop page, that is the one passed as a parameter to the navigator, which is the one invoked whenever a page executes a pop event, for instance, when the user presses the back button on the app bar. In this case, we have an additional operation to do, so we must invoke the method deppop on the route that we receive as a parameter of this method. That's because pages are allowed to manage internally their own navigation stack. So a page may have a list of modals, for instance, inside it, and in that case, it returns false. So if we have false, it means that the page has managed the pop request internally, and we have to do nothing. Otherwise, we have, in both cases, to return a value that tells to the system that if we have managed or not the pop request. True if we did, false if we didn't. I'm using a utility method, which is Tripop. And in our application, since it has only 3 pages, the only case when we have to manage a back event is if we are in the to-do detail page. So if a selected to-do is available in the Upstate. In that case, we clear the selection and we return true to tell the system that we managed the event. Another important method is setting route path, which is the one called by the RouteInformationParser whenever the system requires a new path to show. So it's where the communication between the parser and the delegate happens. We receive the app route path as parameter, and we have to configure our application state to reflect the request that arrived to us from the system. So if the system required to us to show is error page, we just set the variable show error to true and we're done. In this case, we don't have to call notify listeners because whenever a new path arrives, it's the system that already knows that a reload must be done. If it's not an error page, show error is false, and then we check if it's the to-do detail page. In that case, we select the to-do in the Upstate. Otherwise, we can only be in the to-do list page. There is anyway an additional operation to perform, because if the system is requiring us to show the list, but a to-do is selected, we must clear the selection. And that is all. The last thing that is important is to implement the get current configuration property, which is used in this other flow. Because whenever a change happens and the router delegate notify the router that something has changed, the router here requires the new list of pages to the router delegate in order to reflect this event on the application. But it has also to change the URL on browser. So whenever the page changes, we must update the URL bar on our browser. So we do it by getting the current configuration from the router delegate and passing this information back to the route information parser, and that's where the restore route information that we saw before has its importance, because that returns the new location that is passed to the browser that shows it in the bar. So for example, in here, you can see that we have the to-do list pages that asks us to do go to the gym, buy groceries, and write just slide for Droidcon. And when we click on one of the to-dos, we have the URL bar updated, reflecting the current selection. This happens because I have implemented the get current configuration property that returns the current configuration, as the name says. So if show error is true, the current configuration is uproute path.error. If the to-do is not selected, to-do list, otherwise to the detail. So we are using the same model that we used before in the reverse operation. How do we merge all these things together? Just using the method material_app.router, passing to this router the router delegate and the RouteInformationParser. That's all we have to do to group all the things together. Okay, this was an example that an approach that worked well, but only for very simple cases. I used it in an application with 5 or 6 pages, and it became difficult to manage all the events because we have a bunch of variables and we must track of everything inside the navigation logic these variables have been used, and it can easily become complex. So in order to solve this problem, in the Charge Car project, which is an Android and iOS app used for charging electric vehicles, we decided to study a more structured approach, which we implemented using in Flutter, obviously, otherwise I won't be here, using the Bloc library for state management. So we studied different approaches for merging these things together, and we created our own approach in order to have a structured way to manage location inside Flutter. That's the demo app structure. It's not a charge car because it's very complex, but I extracted from this project a list of pages that are more significant in a navigation point of view. So we have a splash screen that loads home after a few seconds. And then from the home, we can go to the registration flow or to the login flow. The registration flow has internally 3 other pages: email and password form, user data form, and payment method. But both this flow redirects the user to the to-do list that we saw before. From the to-do list, we can access to retail or create to-do, or the settings section that is not important for this example. So as we did before, the first important thing to do is to determine how the information parser and the router delegate communicate. So in this example, we used a page configuration class, which is easier to understand from code. So what we did before anything else, we created 2 enums, one with the list of sections that exist in our application. So we have one section value for each of the yellow rectangles, which are the sections of the application. And the page contains the list of all the pages. So we have one value for each of the gray rectangles. The sections actually is not mandatory. You can live without the sections in them. I decided to keep it because I wanted to have a one-on-one relation with the URLs, with the path that the app manages. So, for instance, the registration page is loaded at the path /registration/account, and I wanted to have something corresponding in my model. So I created the section just to keep track of the first part of the path. But if you don't like it, you can remove it and the approach will work anyway. Then we defined all the paths that our app manages. So the splash path is at the root. The account registration is at /registration/account, and so on. So we defined a path for each page. And then we created a model to merge it together. And that's the information that is passed from the parser to the delegate inside the navigation model. This class merges together the path. Every instance corresponds to a page, and it merges together the path that must be unique because I use it as a key, and the couple section UI page. Then we have an additional information, which is route location, which is the path that you see inside the browser. In the browser URL bar, you should think that it's just the same as the path, and for almost all the cases is true, but we have an exceptional case, which is the to-do detail, which has the default path, so /to-do/detail, but then it also has the ID of the to-do. So the easiest way to reach this goal was to create this route location and to overwrite it in order to return even the ID inside the to-do detail page configuration. Then for each pages, we created a constant value that corresponds to this page. So for instance, for the settings account, it says the path is /settings/account, the section is settings, and the UI page is settings account. The exceptional case is to-do detail, that the difference with the other configuration is that the to-do detail has a parameter. So we had to manage the parameter, and it wasn't possible to just create a constant value. So the only thing we had to do was to create an extension of the default page configuration class that added the new parameter to-do ID and overloaded the route location getter in order to return the path and the to-do ID. And that's all for the model. Then we had to implement the RouteInformationParser as before. As we did before, we use the RouteInformation class location property. If it's null, we return the error page config. Otherwise, we use the URI. Then we check the section and page from the URL, and we used a switch to determine which page this configuration corresponds to. So for instance, if we have /registration as section path and /registration/account as page path, the system is requiring us to show the account registration page. So we return the account registration page config. In this case, I found it easily to read to have a nested switch section and page, but as I mentioned before, without the section, you have a single switch and everything is okay. The exceptional case of the to-do detail page has just one difference with the other pages, is that we must check that the URI has at least 3 segments, and we use the third as ID of the to-do. So we return a to-do detail page config with the to-do ID, which is parsed from the third part of the path. The restored information is extremely easy because it just uses the route location property that I mentioned before. Then we have defined a block, which is the central part of the routing, which is a block used only for the routing part of the application. The block state has only one information, which is the list of pages. Notice that it's not the list of page configuration, it's the list of pages. So the routing block internally, whenever receive a new event, convert the page configuration to a new page. And in order to have a better structure, I confined this operation inside the utility class, which is page configuration parser, which has the only goal to get the configuration and return a page. Then we have one event for each of the operations that can be done. So route pop, when the user wants to pop a page, route push for push a new page, and in this case, we have the page configuration parameter. Last route replaced is equal to execute a pop and then a push. Replace the topmost page. And all route replaced is user when, for instance, when we have a deep link and we want to clean up the navigation stack and replace all the pages with new ones. So there is an event for each of these actions. And the goal of the routing block is to receive this event, managing it internally, and update the list of pages. Let's start from the page configuration parser, which has an utility method, which is create page, that returns a material page, which is the same class we used before. The create page wants a widget as a first parameter and the page configuration as second one, and returns a material page that has as UI the widget passed the third parameter, a key, which is a value key that uses the path, the name of the page is the path, and then we pass the page config as arguments to the material page. That's an important point that I'll explain to you in a while. Then what the page configuration parser does is check which page the configuration refers to and to return the corresponding UI. So for instance, add payment method page is the page that manages the payment method. The usual exceptional case of to-do detail has one only difference. So if we must check that the page config is actually a to-do detail page config. Otherwise, it's an error. And if it's a to-do detail page config, we assume that it has the to-do ID information that we must use to provide it to the to-do detail page that requires it as mandatory parameter. Then the state just has the list of pages. The block event are the ones that I just showed to you, and the routing block just map the event to a new list of pages. An important thing to notice is that we cannot have an empty list of pages. So for default, we always load the splash page configs. An important thing is also that whenever a new list of pages arrives, is required to us, I always check that this list is not the same that's actually loaded. That's important, especially in the startup of the application, because we load the splash page, which is the default one. We receive the request from the system to load the default page, which is the splash. and I don't want to make two times the same operation, so I make a check, and in that case, I don't do nothing. What does the router delegate do? The router delegate, in this case, just have a build method that contains a block listener, which listens for the routing block, and whenever the state changes, it invokes notify listeners. Then the navigator has the navigation key, has the on-pop page as before, and returns solely as pages the list of pages that is got from the state of the routing block. You may think why we use the block listener instead of a block builder, because using a block builder, everything on a mobile application will work anyway. But without calling notify listener, the router doesn't know that something has changed, and so it never update the URL bar. The browser gets never updated. So in order to manage in the manual way the navigation 2.0, we have to always call notify listener when something changes. Then the on-pop page, on-pop route have the same structure as before. The only difference is inside the tripop method. The tripop method asks to the routing block if a pop operation can be done. And in that case, add a route popped event to the routing block. The can pop of the routing block, as you may imagine, only check if the list of pages contain at least 2 pages. Otherwise, a pop is not possible. The set new route path is easier than before because it only adds to the routing block the all routes replaced event, passing to it the list of pages which only contains an array that contains the page configuration received as a parameter. And that's all. Okay, in this case, is a simplification. You may also need to receive a list of pages. In this case, I decided to manage only one. Then, the last thing is the get current configuration property that must return the configuration, the page configuration of the topmost page. We get the topmost pages from routing block state pages dot last. But we need a page configuration. So that's why before we had to pass the page configuration as argument to the pages, because we need to pass it as we need to retrieve this information when the router is asking to us the current configuration. So that's how we decided to manage the navigation in our application. We got at this point by passing through a different architecture, which we rejected, which was similar to this one, but has some key differences. In this previous approach, the routing block was just an event dispatcher, and the entire logic of the navigation was inside the router delegate. So the router delegate had the list of pages and had the main algorithm of pages management. That's an error, sorry. It's not the routing block that has a reference to the parser, but in this case, it's the router delegate that uses the page configuration parser. In this approach, we had a routing state for each one of the events that I showed to you before. In this way, whenever, for instance, a route push arrived to the block, it just forwarded and just emitted a new route push in progress state that was used by the router delegate to update its list of pages. So the routing block did not manage the pages, but just was an event dispatcher. Then, after having managed the event, the router delegate used the routing reset in order to bring back the routing state to idle, so no operation required. It has some advantages. First of all, that the page management logic was only inside the router delegate, and that the list of pages was not accessible from the outside. Otherwise, in this architecture, the list of pages is in the routing state, so any component that get reference to the routing block can always get reference to the list of pages. But we found this approach more complex to implement, but especially to understand. So we went for simplicity and we decided to use the first approach, but I don't consider this other one wrong. Just fit less our needs. We had a case to manage, which was the registration section. We wanted to create a section that was reusable. So our idealistic goal was to create a section that could have been got from this application and copied inside another one, and that work with the minimum effort to configure it. And then we had the need to store the information of the registration flow somewhere, because the email and password form generate the email and password data that must arrive at the add payment method page, because it's the add payment method page that sends it to the server. So this information had to flow from here to there and from here to there. One approach could be to pass it as a parameter to the page, but that's very quick and dirty. So we didn't consider it. The other approach was to create a global store, a global block or Cubit, where to put transient information. A way to reach both of these goals, so to get two birds with a stone, was to create a nested navigator. So to create inside the app a registration section which had its own router delegate, independent from the rest of the app. So this router delegate did not depend on the routing block that we just saw. So it was more reusable. That's how we did it. We create a registration section app with its own router delegate. This app had, this section had its own state, which had the transient information I mentioned before, and the page index. The page index tells which page must be loaded at any moment. This information is used by the router delegate to return a list of pages that reflects this state. So if the page index is as least true above the account registration page that's always present, it loads the user data registration page, and that's all. This nested navigator, when the on-pop page is triggered, just get a reference to the registration qubit and invoke the go back of the registration qubit that just set the page index to 1 less. In this way, we had a section with its own nested navigator, its own management of the back button. But to reach that goal, so to manage the back button dispatcher inside the nested navigator, there is another important thing to do, is to create a back button dispatcher as child as the root one, and to invoke on this dispatcher take priority. Otherwise, when the user press back, the priority is at the root dispatcher that will just close our nested section. Otherwise, we don't want it. We want that inside our section, we go back by one page. So we have to create a new back button dispatcher, invoke take priority, and pass this dispatcher to the delegate we just created. In this way, we had a nested section with its own navigator. And that's possible. That's a good approach. Actually, it wasn't for us. Because what happened was that we studied the application with our customer, and we decided together that for the user was better to make an update. When the login operation succeeded, we checked that the user has already a payment method, and if it has not payment method, we go to the add payment method page. In this case, having nested all inside another registration section with its own navigator, it was a bit tricky to reach this page from outside because it was confined to a nested structure. We ended up removing all the update that we did, removing the nested registration section. But I don't want you to think that it's bad to use nested navigator. We didn't consider it enough, the cases. But if you are sure enough that your flow won't change and another page won't have to access some nested pages, that's a perfect approach. That works well. It's reusable. It can allow you to have a local state that that's not accessible from anywhere else. But you have to think it better than I did. Then, last but not least, I just wanted to say thanks to the colleagues that work with me at the project and to Vincenzo that refactored my presentation. And that's all. No, that's an inside joke. That's all. Thank you for having listened to me.